Pulsed amplifiers are devices used to amplify pulsed RF signals. At its input is the pulse intended for amplification. The output is a higher power version of the pulse. How can we characterize a pulsed amplifier's performance to ensure it reproduces the input at a higher power without adding distortions? The answer is using advanced test solutions from Boonton, such as the RTP5000 Series real-time USB peak power sensors and its control software, the Boonton Power Analyzer. The RTP5000 series utilizes real-time power processing, which processes waveform samples in parallel to the acquisition. This enables the RTP5000 series to achieve the fastest measurement rate of 100,000 measurements per second with virtually no gaps or latency. Each measurement is a triplet of peak, minimum, and average power. Other key features include a continuous sample rate of 100 megasamples per second, an effective sample rate of 10 gigasamples per second, 3 nanosecond rise times, 100 picosecond time resolution, 16 automatic pulse measurements, and the ability to make measurements on pulses as narrow as 10 nanoseconds. Let's take a look at an example analysis of a pulsed amplifier with the RTP5000 series and Boonton Power Analyzer. In the software's trace view, users can drag the markers to target a specific region of the pulse for measurements. In this example, channel 1 in yellow is connected to the amplifier input, and channel 2 in blue denotes the amplifier output. The Auto Measure tab opens the Automatic Measurements menu, which includes automatic and marker measurements for the amplifier's input and output signals. The Automatic Measurements table lists up to 16 measurements important for pulsed signals. For example, we can look at the Channel 2 column to determine if droop is occurring. The Marker Measurements table lists measurements related to the draggable markers that we defined earlier. The marker average measurements, for example, can reveal amplifier gain. It's important to note that each table can be edited and customized to display the data needed for your application. Users can export results as a PDF or CSV file to create a report or further analyze performance. While the RTP5000 series for this measurement connects to a PC, the sensors are also compatible with the PMX40 RF power meter for a benchtop test setup. The Boonton PMX40 can provide the same automatic measurement and marker measurement results as the Boonton Power Analyzer software. Visit Boonton.com for more information on high-performance RF and microwave test equipment and solutions for pulsed amplifier characterization.